All right, so it's about 2 minutes. Um, Now, you don't have to tell me what you pick, but I do want to know how many of you have got an answer. Raise your hand so I will have an idea. So, okay, at least you have an answer, right? So I'll tell you what it is. But I guess that for the rest of the class, the reason why that there's nothing hard for you to understand, but you're probably thinking not exactly what they wanted to, in the first place. And that's why it's causing you a little bit more time to figure it out, right? So let's see. The answer is letter B, radical 3 over 2. So the question is finding the value of a cosine P, right? So they're asking for, hey, what is the cosine of this angle? But do you see, well, of course, they labeled a 28, right, at angle 60. So probably you're thinking about finding the missing sides. So you know what? For our students at this point, you're probably not that alerted. But later on, maybe in late April, early March, not late April, early May, when you take the SAT, you're thinking, oh, I'm so good at using the right angle tricks to find out what those missing sides are. Just find them all, and then you're gonna find out whatever, right? Trig functions, will be equal to. But that's not the best way. So I hope you realize how much is the angle P in degrees? 30, right? So it's asking you, hey, what's going on? Am I not able to erase? So basically, I'm asking you, how much is cosine 30 degrees? I know that not everyone can be, that quick, even when it comes to those special angles, right? But at least for 30 and 60, sine and cosine, right? So try to remember it, right? And it turns out, now if you do want to write or use the right triangle to figure it out, 30 degree, right? That opposite is 1, hypotenuse 2, radical 3 is on the adjacent side. So cosine 30 better be adjacent of a hypotenuse, so radical 3 over 2. So that has nothing to do with the actual size of, the longest side, right? I mean, you could figure it out, but the trick is a ratio. Cosine 30 is a definite value, okay? So it doesn't matter how complicated they're making, it seems, but, cosine 30 is cosine 30. All right, so again, so in the SAT, I hope that either you remember radical 3 over 2, because that's even quicker than you just simply type it in the calculator, right? But I think that's nothing wrong if you just type in the calculator and get it, because, you can still get it done within a second. Anyway, so I'm sure that there's no questions about this, since you realize that it's just looking for that missing angle, right? And the cosine value of it. All right. So now the next one, I'll say just be careful, but still, yeah, don't overcomplicate. Right? Be careful, but you know that it still straightforward. Anyway, again, roughly 2 minutes. All right, so about 2 minutes. Oh, by the way, so those questions I picked from one prep XYZ are the hard ones. Right? They have 3 levels. So easy, medium, hard. And those questions I picked 13, 14 questions today, all from the trig, right angle trig. They are the hard ones. All right. Yeah. Doesn't seem that hard, right? Good, good. That's why, there's no point to even try the easy one. Because, if you want to do it. Well, I don't know if it's really like a real SAT question, but the website seems to anyway, so I'm saying that if you find some of the questions hard, it meant to be, but if you find some of the questions easy today, good, right? But let's say raise a hand if you have an answer. Good. Now, keep your hand up if you draw a right triangle. Good, not, well, actually quite a few students, right? I think that one of the best way to deal with geometry problem, right? So you know why they don't draw the triangle for you, right? There's a question just now, they have the triangle, they're aiming for something else, but this time, if you had a triangle there, you will figure out right away. So let me tell you the answer. It's 20 over 29. You guys all get it? No? Okay. Oh, okay. Well, yeah, well, now this is something you guys have to pay attention to. I don't know. Do you think that they will give you points if you don't simplify it? I think they should, right? But they don't have to. It is, yeah, you're right. So, but I mean, if you're taking in the future in your dream school, taking an engineering class or a science class, don't simplify the fractions, not a big deal. But taking SAT math, I mean, those mathematicians have a strong, preference for certain things. Anyway, so let me put the work down. So then if you ask me for the notes, you're gonna have it. All right, so let's say N is the right angle. So this is N, right? So what is that? M and P. M and P. Doesn't matter, as long as I know that it's the right angle. Oh, thank you. Yeah, please remind me, all right, cool. So they say, I know the sine of this angle, right? So let's call it angle M. They want the sine of P. I mean, yes, you could. I mean, just go ahead and label sine of M as what? Opposite over hypotenuse. So opposite is 36, right? Hypotenuse, 87. Then you need to figure out what the remaining side is, right? So go ahead and put MN equals square root. Now, since you're looking for one of the shorter side, so you go the longest side, 87 square minus 63 square, right? Then you get whatever it is, and you then do sine P, which is again the opposite, which is Mn, right? Over MP, so be whatever it is over 87, and surprisingly, it's simplifiable, right? So it'll be 20 over 29. Okay, so that's actually a standard way, right? Nothing wrong with it, and I do want you guys to be fast once you draw the triangle, find out the missing side, and go by the definition of the sine, right? So that's one way. Or let's say method number 1. Now here's another way, slightly different, but not that insanely different. So what is the relation between angle M and angle P? These two angles are called what kind of angles? Complementary angles, right? Therefore, if I'm looking for, say it again, M and P, yeah, complementary, right? Yeah, so now, what is the most important identity you should know about complementary angles in trig? Right, so L is 390, right? So do we have an identity that's therefore the function and its cofunction, right, evaluated at complementary angles, right? That means if I'm looking at sine P, it's also equal to cosine of angle M. Does it make sense? Okay, so now I know sine M. How do I find cosine M? You could do that, but let's say, remember that Pythagorean identity, sine of any angle square of the sine of any angle plus cosine square of any angle will be 1, right? Therefore, cosine M must be square root of 1 minus sine squared M, right? And you know what sine squared M, plug it in, and you're going to get the same answer, right? So now, here's my question for you guys. Are these two methods really that different? Why not? Right. Or, not even a different way, just seems different, but eventually, you will, right. So listen to this. What do we call it? Pythagorean identity, right? What do we call? Yes, they're the same, right? So now, I guess that right now, most of you, I might be wrong, are still more used to Pythagorean theorem, right? So, but in the future, trust me that you will find Pythagorean identity a lot more natural because you're gonna get tons of those identities. See how powerful it is, because what are odds that you're dealing with the real dimensions? The functions are the way to go. Not to mention you're gonna go into calculus, right? What do you think the calculus is for? It's for analyzing functions. They literally call it so my wife majored in math, and they learn math and calculus and under a different name. They say functional analysis. So I asked her, what is functional analysis? She said calculus. Oh, okay. I do physics and I learn calculus. You guys, just because you're math students, you learn functional analysis, but it's the same thing. So ultimately, if you're doing algebra, you feel like the algebra, probably or solving equations, right? That kind of hard stuff. And most people hate functions because they're just abstract. Unfortunately, if you want to do well in calculus, then you have to know very well about functions. Anyway, now let's move on. Again, 2 minutes. Well, let me see if I can just put a timer. You know what? Never mind. I don't want to cause too much anxiety. Go ahead. Number 3. I'll wait for roughly 2 minutes. Oh. All right, so that's about 10 minutes. Again, let me know if you have an answer at this point. Raise your hand. Okay. Well, still, I mean, we're on the right track, because 1 or 2 minutes. Because remember that those are the hard questions. Can you imagine that most of the questions are not supposed to be at the level, right? Even when it comes to trig. The answer is letter B. Okay. So wherever I get it, let me still put down some work. And I still suggest that you guys draw a right triangle, right? And let's say what is the right angle here? It didn't tell us, right? But what do you think will be the right? So let's say the longest side is AC, right? So this is AC. So the opposite of AC must be the right angle, right? This must be the B. So AB is 65, right? BC doesn't look like 72, but don't worry about it. It's just it's not draw to scale, right? AC is 97. But now they say some other triangle which is similar to ABC, right? So they say A corresponds to X, B corresponds to Y. Then what angle in ABC corresponding to the Z? C, right? So basically, cosine Z is nothing but cosine C, right? Does it make sense? Now, when they say angles are corresponding to each other, that means they are equal in measure, right? They're in the same, measurement in degrees or radians. Therefore, you just have to find out what is cosine C. Cosine C is adjacent of the hypotenuse, right? Therefore, it's 72 over 97. Okay. So I mean, it's a problem checking the corresponding sides, right, of a similar triangle. And I hope you realize that the similar shapes all have the same interior angles corresponding to each other, right? But the sides are proportional. But when the sides are equal, then you're looking at congruent triangles or congruent shapes. Anyway, so not a big deal. It's just more like a conceptual question, even though they rated it as a hard question. All right, so now this one. That's a little bit tricky, but again, I might be wrong. I think that you guys are pretty good at, a lot of questions, at, at this moment. But I do want to draw something to make sure that you're looking at the things they want you to investigate. All right, so I'll give you 2 or maybe up to 3 minutes. Make sure you do some sketch, so you will see something that we learn this semester is all you need to know. Do you mind doing it? What's up? Mm-hmm.
How is it?
Yeah. So, but make sure that you put the point. Oh, I don't know if it's doing. Draw that to see what kind of angle, they're talking about, what it looks like, and how these two angles are related to each other. But you're right, it is cutting the angle. Right? That's what people are not very used to. I think this one deserves to be a hard question because it's not even multiple choice, right? It's hard to guess. But you'd be surprised at how easy the answer later turns out to be. I'll wait for 1 more minute. The key is to visualize. Okay. Mm-hmm.
Consider signing sign by the
Mm-hmm.
sign.
Okay. Well, anyone have figured it out already? The rest of the class? Do you feel like sharing what you thought?
So,
All right. Yeah. What do you think, Nicole? Okay. But could you repeat the most important part of the reasoning? Why these two sine of this angle, which is PQM, PQM, right? This angle, sine of this angle is equal to cosine of that angle. Why is that? It's going to be some very special relation between these two angles. Corresponding angles, or Akim says cofunction identities, right? Complementary angles. So that's what you're thinking about, right? I think that you first told me the opposite angles, right? Then, but I sense that you're talking about complementary angles, right? So yes, it is just asking if you do remember the cofunction identity. You see that this question has nothing to do with the actual sides. They do that just to confuse you. And you see that you didn't, well, how many of you draw that point to see what angles PQM and MQR look like? You did, right? So now you're so close because now I have to think, why are you talking about sine and cosine? Look at the angles. Now you know what? If you didn't label the angles, label the angles so then you know you're looking at these two angles and you should see that right away they add to be 90. And as soon as you realize that two angles add to be 90, it's cofunction. Maybe it doesn't help, but it won't hurt if you just remind yourself cofunction identity, right? Therefore, these two are the same. So subtract them, you get 0. So now you see that it doesn't matter what the point M is. I know that the Quinn tried the M to be at such a location that you're gonna get a right angle, right? You can do that, but assuming you're gonna draw a special case, because you know what? If most likely the question in SAT works out with a special case, it's gonna work out in general, right? It won't hurt if you just try some special, scenarios. But in this case, turns out, you know what? I might want to do a more general sketch that, when you guys refer to it, it's not like, I'm asking you to always think about the special ones. So it turns out I can put M to be anywhere, right? This is M, and I'll draw, oops, that line here, right? So because the angle PQM plus the angle MQR is 90 degree, right? They're cofunction identity, they're complementary angles. Therefore, sine of angle PQM is equal to cosine angle MQR. Therefore, you get 0, right? That's why I think that is such a good problem. Okay. All right. So, like I said, please. Yeah, Reese. Yes. Even the angles are not acute angles anymore. So, which you can try this. Now, here's a, I'm glad you asked that. Sine negative 10 degree. Oops, I bet. Is that true? Sine negative 10. Is it equal to cosine 100? In what way? They add to be 90. So that means the complementary angles might be not necessarily positive angles. Okay. They add to be 90. That's all you need. Okay. So it works. It works in general. As long as two angles add to be 90, it could be anything. As long as they add up to be 90, cofunction identities will work. Yes, right. No, right, exactly. So all you want is two angles add to be 90 or pi over 2, then the cofunctions are equal. Anyway, so that's what we call identity, right? We didn't say that it's a conclusion provided, blah, 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 right? It's identity, that means it's true no matter what. So now, let's hope that, you guys remember some of the basic identities from our class so far to help you with number 5. All right, go ahead. I think that you should be able to get it done within 2-3 minutes. All right, but let's aim for 2 minutes. But this time, I do want you guys to tell me what you're gonna pick. All right, so I hope that after quite a few questions about those basic identities, right? And I think that so far we only talked about 2 today, right? So hope that you can combine them. All right, so that's roughly 2 minutes already. Now raise your hand and tell me what you pick. Like a Schrodinger's fingers. Well, you get half point. Yeah, one of these. Yeah. So it is letter A. All right. So now, Reese, would you mind tell us how you did that? Okay, so this is right sine 56. Right now, don't feel like you have to remember 56 and 34 adds to be 90. Check that with the calculator. Right, subtract 34 from 90. Good. So, and what do you do in the second term? Okay, so now would you write it as, say, instead of sine 34, maybe let's put it cosine. Oh, they do that? Okay, right. Thank you. So you're right. So let's write this as sine 34, right? There you go, right? Okay. And also you see that letter A is also equivalent to sine 56, sine square 56 degree plus cosine square 56 degree. You guys agree? Because sine 34 is, cosine 56, right? And is also equal to, let's say cosine 36, not 36, 34, cosine square 34 degree plus sine 34 degree, sine square 34, right? Do you see that? This is probably also, the part that a lot of people hate, right? So there's so many different versions. But if you already see that what's going on, you can even get yourself all that many different versions. That means you can be very flexible with whatever versions you want, right? So you're not stuck with a certain version of the identity. Anyway, very good. All right, let's move on to number 6. Again, 2 minutes. Yeah, I can do it in a standard way, but it'll be a lot quicker if you realize some cool identities. Is it close enough, or like at least looks closer to anything? Very different. All right. So I'll wait for just a little bit. Let's see. Well, at the same time, let me draw the right triangle. I think that this is, what you need anyway. You can probably picture the triangle in your head, which is good, right? So let's say we have a right angle. Yes, Benjamin. Okay, thank you. Thank you. Yeah. So we have, you know what? It doesn't matter. Let's just label it D, E, F, right? So angle D, the tangent of angle D is radical 11 over 5. Then what about the tangent of angle F? I mean, again, you see that these two angles are complementary angles, right? Therefore, tangent F is what? Cotangent D, right? Agree? Cofunction identities. Now, I know tangent D. Tangent D is radical 11 over 5. Who knows? how the tangent and cotangent are related to each other. They are reciprocal. Good. So that's why it's 1 over tangent D, and it's 5 over radical 11, right? Letter C. You guys remember when sometimes the question asks you guys to rationalize the denominator, I said you don't have to. The SAT problem sometimes have the radical on the denominator, right? It's just, I mean, I'll say rationalizing the denominator is one of the, I don't know, like silly thing that being asking the students to do for no reason. Anyway, now let's do one more, then you know, we'll call it a day. Oh, that's actually a harder one. Maybe not. It's just, you know, they describe it in a complicated way. But trust me, you know, you being fine so far, you know, you're getting all those little traps and you figure it out already. This is not really that bad. If I try this problem as the first question, then it will be bad. Yeah, you guys can start packing about this. Okay, you know, so it's now Friday. Hopefully you have nothing else to do later. All right. But please don't forget that, you know, homework that's due tonight, 5155. Figure it out? No, but I think you're doing the right thing. Yeah. So it's probably some little mistake somewhere, but you're definitely thinking about the right thing. I can tell. All right. Anyway, so no, I'll let you guys figure out what the answer is. All right. You're good to go. Yes. All right. See that? It's again, you know, that kind of an interesting relation, right? Sine A, cosine B. So now you should be sensitive to these things. All right. No. All right. You too. You too.